Alright, hello computer science students. In this video we're going to talk about a client class, or sometimes it's called a driver class, and how we can move our main method to that client class or that driver class and just basically model the real world use of programs a little bit better. So we're going to start off with our slope calculator app, our good friend that has all these methods and has the main down here in the bottom. And just as a little reminder of the execution flow of that, this is just an abbreviated version where those same methods, get points, calculate slope, print results, and main, they're shown here, but none of the actual implementation code is in there, just actually just the print line statements. Whenever this program is first run, we all know that Java will first enter into this file or into this class, so to speak, not at the beginning, but rather it's going to jump in and start executing down here at the main. So it's going to skip all this stuff up here at the top. So it's going to go to the main, and here we have slope calculator app equals new slope calculator. What we're doing there is creating a new object of type slope calculator, and we're giving it the name app, interestingly enough. And then we're going to tell this app to do things. Hey app, get the points. Hey app, calculate the slope. App, print the results. And whenever we go to this next line, app.getPoints, the execution will then jump up to the get points and will run through all of these lines. Then it will not continue on through the rest of the file. Actually, when it hits this close brace, it's going to jump back down and say, all right, I finished the get points. Now I'm going to go back and execute this line, app.calculateSlope. So jump up to that method there, execute those lines. When it hits this close brace, it will continue on the next line of code, app.printResults. Go to that method, execute those lines, and then we're done. It's pretty straightforward. It's not a bad setup, but it's not a great way of really kind of modeling or programming the way that real programs are used out there in the real world. So here are the problems with that main method inside the same class that it runs, or that runs it. First off, like I said, it doesn't really model the real world use of programs. Programs don't normally just run themselves all by themselves. They're called and they are used by other programs and by other users. And we want to simulate that. We want to write our program and then allow other programs to access it. It also requires you to compile both what we call the front end, which is where the main is, and the back end, where the class definition is, each time we make a change to the program. And this can be a long process. In this example right here, okay, yeah, there's not a whole lot going on. It's going to take a couple of seconds tops, but we do want to simulate, like I said, real world situations. Another thing is it doesn't allow you to hide your data from the main, since the main can actually accidentally change the instance variables values. You may not intend to do it, but since this main is in the same class as these other methods, we may accidentally call something inside the main that we shouldn't, and we really want to try to protect our data and get an accurate result. So since main is inside the class, it has the same, all these variables, and the instance variables themselves are still the main has visibility of those variables. That's going to possibly cause an issue. It may not, but we never know. But what I think the nail in the coffin here for why we don't want main in the same class that it runs is it's just weird. You've got a class talking to the blueprint of itself. I mean, how weird is that? If you technically think about this, these methods describe how a class behaves. And then in sort of its behavior is also how it talks to itself, which is just strange to me. I don't know. So maybe it's not as strange to you, but computer scientists, we generally don't like that too much. So here's what we're going to do. We're going to start off, and this is just the slope calculator demonstration file, the lab 10.0a. We're going to copy all of that whole program, go over here to Dr. Java, paste it in, there we go. Maybe do a little auto formatting. Sure, looks great. We're going to save it, not as sample.txt, but as slope calculator and we'll add the .java there at the end. We can compile it. And run it. And we'll say we'll go from the point 1, 2 to the point 5, 6. And one of the things you may notice here, there's actually a little bit of an error. We get x2, oh, x1, x2, y1, y2. Probably should have changed that to x1, y1, x2, y2. But anyway, so the point here is not so much that we might have some logic errors with that, but here we have the main method down there. Now what I'm going to show you is how we can actually have an entirely separate class that will implement this. It'll have the main method. So I'm actually going to keep this as is. It's not too terribly bad. I'm going to have a new file over here, and I'm really lazy and I don't like to type things if I don't have to. I'm just going to grab this whole first little bit here, the public class, and on the import statement, since I might need that, I'm not sure, but here we go. So we got the import statement, public class. Instead, I'm going to call this slope driver. Maybe I call it slope client or something like that. And go down here, and what I'm going to do is I'm actually going to cut out the main part. Yank that out completely. And that gets put over here in my slope driver so that I have a class. Sometimes it's called a driver class, sometimes you could call it a client class. You'll see both of those names thrown around. That just has a main. And we're going to create a slope calculator app. Now, I might go up here and change this just so that I can differentiate this in my programs here. I'm going to call this slope calculator 2 because this is the one without the main. And that's there. And over here I've got slope driver. I'm going to save this one, call it slope driver. That's fine. Slope calculator 2, I'm going to go and say file, save as. I'm going to call this slope calculator 2.java. I'm going to compile this. So now I've got a slope calculator 2 and I have slope driver, which if you look here, I'm going to make sure that my slope driver creates a slope calculator 2 app equals new slope calculator 2 app.getPoints, app.calculateSlope, and app.print results. So it's the same thing as I had before. Just like I said, you saw me, I cut and pasted the main, but there's no main over here now in slope calculator 2. So actually, if I compile this, which I guess I did that earlier, and I try to run slope calculator 2, I'm going to get an error message. Static error. This class does not have a static void main method accepting string brackets, string array. And you say, that's right, yeah, I took the main method out. I cannot actually run and test this class all by itself. I have to have a client who calls it, or a driver class which is going to call it. So if I go over here, slope driver, this has already been compiled. I hit run. Then it's going to go to the main method and start executing this. And there we go. You can see it's going to run just the way that I want it. 1, 2, 4, 5, whatever. So what's actually happening is the slope driver is compiling to a slope driver.class file, and the slope calculator 2 was compiled to a slope calculator 2.class file. And those files, the .class files, are interacting, they're talking to each other. In fact, if I go over here, this is the folder where I created everything. You can look. I have slope calculator. This is the original right here. This is the .java file for that first one. It's you can see over here is this Java file. When I compiled that, it made the slope calculator class file. And of course, this is always confusing. And in this version of Windows, the slope calculator, since it's really just it's text, it's going to look like the icon here is nice and text there, but and then there's a J for the class file. So you tend to think, oh, the class file is the Java file. No, it's not. Then down here you've got the slope calculator 2, and then that was compiled to its class file. And then the slope driver, the Java file, the source file, and then its class file. And then you can see this little temporary file that was made whenever I ran it. That just happens from time to time whenever you run a program in Dr. Java. So going back there to the programs, we have the slope driver, which has the main, and that just calls the methods. And this is really advantageous because let's say this is the, like I said, the front end. We'll use an example of an app on a phone. This is, what you see at the front. This is where you're hitting the buttons or swiping across, and it's displaying information. You can change how it's going to do all of that, the front end, what you're seeing or how you're executing things. You can update that, no problem. I could call get points again, or I could put this in a loop, or I could have if statements here. And I don't have to go back and recompile or mess with Slope Calculator 2 at all. That's just all intact. So I can change, maybe the look and feel, or how it interacts, or how many times it goes around. It's called and executed and stuff like that. I can change that up in the front here. Or maybe there's a problem with my code. Maybe I need to change this formula, or I want to add some more features or something like that. Maybe I had a typo or whatever. I can go ahead and change that, compile it, and run it, or compile it rather, the Slope Calculator 2, the back end, so to speak, the underlying logic of the program. I can update this, and I don't have to mess with Slope Driver at all, because it's still going to utilize, these method calls and whatnot. So that allows a little bit of separation. Plus, I know now that Slope Calculator 2 can work with any other program because I tested it with my client class or my driver class here. So lots of different reasons why this is the far superior method. In all your future programs, you're going to have a driver class or a client class running your code. So you're no longer going to be able to keep that main inside the class. You're going to have at least 2 classes for every program. Sometimes we start getting into some inheritance and some more complicated things. You're going to have multiple classes, inheritance and interfaces, and all sorts of that fun stuff. So anyway, that's why we want to have a driver class. And quite frankly, if you ask me, this just looks so much better without the main. It doesn't look weird. All right, thanks for watching.